This video is going to show you how to run a confirmatory factor analysis in M+. If you watched my previous video, we were looking at two constructs and their items and whether they're correlated. So we're going to do a similar model here, but we're going to use our data instead of Larry's data from Karma. This model that we're proposing is that in a sample of hurricane survivors, we're going to see that two latent constructs are related. So one of our constructs is global belief violation. These items basically assess the hurricane changed my view of the world, my view of God, etc. Kind of these global beliefs and that were violated by the storm and how severe that was. And then this other latent variable is flood exposure. It's basically 6 items of how much you were affected by the flooding that occurred after the hurricane. So my apologies for kind of a hastily made and sloppily made diagram, but I think you'll get the idea. So this model we're proposing is that the 5 items are going, or the latent variable is going to predict the 5 items and their errors, and flood exposure is going to predict these 6 items, and that these two things are going to be correlated with each other. So if you've never prepared a file for M+, this is basically what it looks like, all your data without headers running in columns. We do have a video already made about how to do that from SPSS, and I encourage you to review that. But basically, if we go over to M+, we're going to go through how to set up a CFA and how to interpret some of the output. So you're going to want to copy all this syntax and change anything relevant to your data. There's also a lot of resources online that I will talk about a little bit at the end. So basically you're going to want to name what you're running. So I'm going to name this one CFA global violation and flood exposure full. Okay, so then you're going to specify your data. So this one is Hurricane Matthew J.dat, and it's got to be in the same folder that you're going to run this input. Next, you're going to name your variables. So this is referring to the columns, and you're going to have to name them because the DAT file doesn't let you have column headers. So this data that I have has a lot more than what we're going to be using. It's got global meaning violation items, it's got PTSD, that's the PCL, it's got resource loss, and it's got flood exposure. So because those are in the data, I have to name all of those items, but we're not going to be using all them. So there's a lot of different ways to do this, but I find this one kind of simple. So you name all your items, and then you tell M+ which ones you want to use. So for this path analysis, as a reminder, we're only going to be using these 11 items, 5 belief violations and 6 flood exposure items. So this is here, use variables are, and also notice that everything ends in a semicolon that basically lets M+ know you're done with that part. M+ also wants you to identify missing variables. So if you saw mine, I had some missing variables here. So I made them 999, some nonsense number that's never going to show up in your data. So missing are all 9999. That tells M+ basically to ignore those numbers. Otherwise, it's going to try to use 999 as part of your data set, which is going to make it go not good. Okay, next in your analysis, there's a lot of different theories on this, and I'm not going to go into these specifically, but it basically is kind of setting some of the parameters of your CFA. So this is a maximum likelihood, and you're going to do 1,000 iterations, and I don't even really know what those last two mean, but these are typically you just take what's been done before, or if you really want to get into the statistics, you can kind of research what those are in particular. Finally, we're going to set our model, and here it is for reference. I'm going to pull it up next to it. So we're saying that there's a latent variable belief violation made up of these 5 items. That's what by refers to, by. So we have these 5 items, global belief violation. Okay, that's how we set that up. Next, we have flood exposure by there's 6 items. That's right here. Okay, simple enough. Just use the by function. Finally, to set that correlation, we're going to use the width, FE with BV. Don't forget my semicolon there. Finally, for the output, you are going to, there's a lot of different things you can put here. I like making it standardized so everything comes out as a correlation. I like to see the residuals, mod indices. Tech 1 also I'll show you first. That's kind of a handy little guide to make sure you're running what you thought you were. So we're going to run it. And yes, we want to save. Okay, so the first thing on the output is it's going to have what you put in there on the top. And I'm going to jump down to the Tech 1 output all at the bottom. We're not going to go through all these because there's a lot of information. So the there's the one, technical 1 output. This can be kind of a good way to make sure that you are running the model you thought you were running. Simply put, everything that has a number is something is a parameter that's being estimated. So for example, these Greek terms all refer to different parts of the model. We're not going to cover all of them. But lambda, for example, is your factor loadings. This refers to how much your latent variable predicts what you're going to score on an item. M plus by custom kind of ignores the first one. We talked about this a little bit in the last video. Basically, you can't estimate all parameters because there's just going to be too many unknowns. And you can change which one does this using some different coding language, which we won't get into today. But basically, it's looking at, these are the ones that are being estimated. These are being estimated. Theta refers to the error of each item. So GMSV 1, 2, 3, and again, these numbers refer to something that's being estimated. And where 0, there was nothing being estimated there. So we covered theta, we covered lambda, and finally, psi is going to be referring to the correlations between the latent variables. So that lets you know what was estimated and then where you can find them. So the last thing we're going to do in this video is usually what you do with a CFA, which is looking at how well your data fits the model you're proposing. So we're going to go to this section on chi-square. So one thing I like about here, and Larry recommended strongly, is to double check your degrees of freedom. That was covered in the last video, but this number does match what I want. It's basically looking at the number of items in the matrix minus how many parameters you're estimating. So that number is what I wanted. That's good. So now we're basically going to go through all the different fit indices talked about in the last video. So the chi-square of model fit is 0. That's not good. You want that to be a non-significant in this case. Basically, yeah, we're going to see that there's a lot of problems in this model, which is okay. This is just a demonstration. RMSEA, if you remember from our last video, we want that to be less than 0.05 or 0.08, and we have 0.111. Again, not great. CFI 0.837, we want something over 0.90, again, not good. And then we have the SRMR, which is a 0.067. We want something less than 0.1, so we met one of the criteria. So basically what this is saying, as a review from the last video, is that this model that we're proposing, based on the data from these items, doesn't really seem to hold. The iterative process, the repeated process that was that the M+ software was looking at, is basically saying the data you have doesn't really seem to suggest this is a good model. I know from other analyses that I've run that there are just a host of problems with these items. For example, in global belief violation, this third item is pretty bad and doesn't hang well with the others. And then in flood exposure is just a mess of an item, or mess of a measurement. Mess of a measure. So basically what we can conclude is that this isn't a reasonable model based on the data we have. So we could go a lot of different ways from here. We could look at other measures. We could look at the measures in particular to figure out what's wrong with them. But basically, before we even wanted to make some prediction, like global belief violation predicts flood exposure, we know that there are some problems and we should probably stop now before we go too far.